And that's all. So the OpenCV AI Kit, the whole premise is it makes that easy to use and accessible. Whereas this, you can only do neural inference. When you use this thing in the OpenCV AI Kit, you get all the crazy powerful functionality and kind of drag and drop flexibility is what we've implemented. So you can like tie all those pieces together to solve really complex computer vision problems, just putting this in your product effectively.
Hi, everybody, and welcome. This is Augment the Startups. We got an interview with Brandon Gilles. Am I pronouncing it right?
That's right. Yeah, thanks.
Okay, cool. So how's life in lockdown?
Oh man, so our company is largely remote anyways. So at least from like the work standpoint, it's going well. But yeah, it's weird. It's definitely weird. How about you?
Yeah, we're enjoying it here. Just working from home. You know, lockdown regulations are very strict this side in South Africa. Where are you from?
So we're north of Denver in Colorado in the US.
Okay, that's cool. So for all of those who don't know, we have Brandon Gilles in our virtual studio, the CEO of Luxonis, and he has launched the OpenCV AI Kit, which is a tiny, powerful, and open source spatial AI system. And you've launched it on Kickstarter, right?
Yep.
So your original goal was $20,000 and right now, currently, as we're speaking, it's reached over $700,000. That
That's
is
right.
amazing. How does that feel?
Yeah, it's really gratifying. Working as a startup, like probably one of the biggest dangers is that you're making something that no one cares about. Unless you're doing like, nuclear fusion or something, like the chances are you'll pull off what you like seek to pull off, but there's a high risk that you make something that just no one wants. So this Kickstarter is really validating in that it said, okay, like people do actually want this. Like we are making, like we of course always thought it was super useful, but like the world does find it useful. And then we're super excited, most importantly, to get it in the hands of people who are going to go build things with it. This is like, it's such a new capability to have this like spatial AI in an embedded system. And we're really excited to see across so many industries what people are going to build. And so that's the thing we're most excited about, not the monetary, but how many backers there are. So I think it's like, it looks like we're probably going to get 4,000 backers total, which is awesome. That's potentially 4,000 different applications. And we've seen some really interesting ones like visual assistance for the blind probably being one of the coolest ones so far.
It's really taken off. I mean, some people compare it to like the Raspberry Pi of its time. So how do you feel about that?
Yeah, I think it's a really good comparison. So the Raspberry Pi did for like just allowing anyone to do programming on a small system that you could put anywhere. We're trying to accomplish the same thing for this like embedded spatial AI. So allowing robotics to perceive the world and making it equally as easy to use and easy to go integrate. And also open source. So you can go build your own thing about it. You can take even the hardware design files and go build around it, go build around the module.
Yeah. Okay. Before we get started on all the main questions, we're just getting warmed up now. I just want to mention that all the links to the kit will be down below, as well as the link to my YOLO version 4 course. And for those all watching, if you want to see more podcast interviews, please like and subscribe, right? Okay, so Brandon, tell us a bit about yourself. What do you do?
Yeah, what do I do? So I'm the founder and CEO of Luxonis. I'm the chief architect of the OpenCV AI Kit. So that's my role in this whole thing. I work closely with Dr. Malik to bring the OpenCV AI Kit to the OpenCV community.
Oh, nice. And how did you get started in the space? Like after university, what is your journey like up until this point?
Yeah, that's a great question. So even in university, I had been very interested in a lot of different subjects in engineering, not just electrical engineering. I even didn't want to like subdiscipline in electrical engineering. And so then when you kind of had to, I tried to stay as broad as possible in EE. So I've done all sorts of things after college. I did aerospace work. I did like nitty gritty, like kind of researchy radio frequency electronics. So including direction finding, geolocation systems, multilateration systems. And then moved into, I even did wireless charging at one point.
Qi charging?
Yeah. So it was a precursor to that. It was called Wild Charge. And it was actually like a it was wireless but contacted charging. So it was like a clever geometry solution. So you could get like 99% efficiency out of it. But yeah, G is, I think, taken off and is now just like the de facto as far as I understand it. So this was a startup back in 2009 that had some traction for a bit. And then I moved into like commercial wireless, so like business Wi-Fi and stuff like that. And one of my mentors leaving that job, we all really liked my job, definitely, or that job. That was the most like satisfying and interesting like job I had ever had. So when one of my mentors left, it was a bit of a shock because everything was going well and like winning cures all. And so I interviewed him when he was leaving, and he was like, "Well, this whole artificial intelligence boom is going to be the biggest opportunity of my whole life. And this is this guy I look up to, extremely successful. And I knew nothing about AI at the time, like literally nothing. Like the only memory I had was from like 2004, probably, with a college roommate talking to me about how useless it was, like with Lisp. So
it has grown over the times, like from that time.
Yeah, absolutely. So I started Googling like 2012, and then I found out like, oh, okay, well, I was like, as of that conversation, that's 2016. So I was like, all right, well, I missed out on like 4 years, right? Of like, there's like revolutionary techniques in AI that started really in 2012 with like, NVIDIA GPUs and deep learning and in all the like, ImageNet and being able to beat the best algorithms in the world. So I was like, holy cow, I missed a huge wave. And I started to realize, okay, I've missed this big like cloud, big computing wave. But it looks like actually trying to apply this to like an embedded system is still impossible. So maybe I could do something there. Maybe I could like add some value by bringing this into embedded devices. And that was another one of the roles that I had traditionally played, is all around like embedded systems, like whether it was Wi-Fi or
it probably wasn't impossible. It was just like really, really, really hard to do back then.
Yep. And the chipsets were just starting to come out. And so I was like watching those. And I actually left my job then to start something around like embedded AI and computer vision. And it was actually to do like kind of augmented reality, to make a kit that would allow like laser tag facilities, if you're familiar with those, to do like multiplayer augmented reality by like using onboard computer vision to detect where you are, whether other players are. And it was around that time that kind of tragedy struck like around me, not directly close, but there were a bunch of vehicle accidents. So actually bicycle accidents where friends, family, colleagues were hit riding their bikes to and from work. And I was, already doing all this embedded CD and AI stuff. And I was like, well, could you actually make like an early warning device? So like you could tell when a car is on your trajectory, and then like proactively try to warn the biker and warn the car. And I discovered through prototyping a solution that actually worked, that the combination of depth perception and AI was incredibly powerful and really easy to use. Like my first prototype only took maybe 2 hours to write the code, and it worked brilliantly. And that's not because I'm a great programmer. Yeah, it was using an Intel. This was before we made OAK. So it was using an Intel D435, a Raspberry Pi, and a neural compute stick. It was really inefficient and used tons of power. It was only 3 frames per second. But it taught me how powerful that combination was. And then when I went to try to productize something, I realized, oh, well, you can't actually build a product. You can build prototypes, or if you have like a huge robot or something that can have a whole computer, you can do that. And then I discovered the Myriad X, which is at the basis of this, which was really architected to allow that sort of spatial AI system. And that was kind of like what then led us down the path.
So how big is your team currently?
So it's kind of bifurcated into 2. So we have about 10 total that are working on like the core enabling firmware, hardware, software, training suites. That's the platform itself. But then that's in addition to this huge OpenCV community, and then also the core OpenCV team, which like the core OpenCV team's quite large itself. So if you throw that in there, then the numbers get really big. But the folks who are working directly on this, myself included, about 10.
Okay, nice. So let's get to the fun part, which is about your OpenCV AI Kit. Sometimes I get mixed up. I say OpenAI. But OpenCV AI Kit. So as I mentioned earlier, your Kickstarter is doing incredibly well, just like blown up, just phenomenal. What are they all about?
Yeah, absolutely. So it kind of dovetails from that backstory. So traditional AI techniques, are monocular, and even techniques that use stereo depth data in their training can be painful to work with because you have to record depth data, you have to have the exact type of sensor. So the whole premise of this is it allows embedded AI and it allows embedded spatial AI. So you can, this is the board itself on a mount, and then you can take the module and like put it into a product, like actually embed this little thing into a product.
Just plug and play.
And you can, yeah, it's plug and play. It's got this 100-pin connector that are really common on these, easy to solder. And then you can interface over USB. We have variants that allow UART. Actually, on this interface, there's UART, I2C, SPI, and some other interfaces. And what this allows you is to harness like spatial AI. So what an object is, where it is in a tiny embedded thing, which is we discovered is crazy powerful. And let's see, then the other part of that is you don't have to use models that are trained with depth data. And that's really important because there's this huge wealth of libraries that exist and data sets that exist for 2D, like for YOLO, right? For object detectors or image classifiers. So the kit allows you to run things in two ways. You can do what we call monocular neural inference fused with stereo depth, which is like choose a camera, run AI on it, run YOLO, for example, on it. And then the system will run stereo depth in the background. And then, you know, you get like a bounding box, like a face, right?
Yeah.
And the stereo depth
fusion
then
between
fuses.
the fusion as well as the AI depth that it's getting.
Yeah. Yeah, exactly. And then that gives you the 3D position of the face. And that works great for objects or relatively big things like any object detector, as long as it's not a tiny object. And for tiny objects or things like getting 3D pose information, you can run those, what's called stereo neural inference. So if you have a pose detector, say it's a 2D pose, or you have a facial landmark 2D, you can run those in parallel on both cameras and then triangulate the results. So like, for example, I have glasses on and you see they're reflecting all over the place. That would mess up typical stereo, but when you run neural inference in parallel, it doesn't get distracted. It still knows those are the eyes and it still triangulates properly. So those are the two modes that it allows. And importantly, you don't need any previous training on depth data or anything. You can just use standard neural models, and then this augments it in those two different ways to give you those three-dimensional results.
That's amazing. So what pain points were you trying to solve? I know you mentioned earlier about people riding their bikes on the street and trying to avoid accidents as well. What other pain points? Was that the driving one, or were there others?
That's what made us discover how useful that combination is, the combination of depth fused with AI in those two different modalities. But then the main pain point we were trying to solve is this was a solvable problem if you're willing to throw multiple components on it, if you're okay for it to be like high power, relatively high volume, largely like you have to have like cables between things. But it was not a solvable problem if you just wanted to make like a device. And as we thought about how powerful this was, even just brainstorming industries, we're like, this has to be useful in agriculture. This has to be useful like in all sorts of other like autonomy systems where you can't solve the problem if you have some big cobbled together cable solution. Like a lot of times it has to be like a tiny thing. So that's the main pain point.
Sometimes people use the Xbox Connect and the Connect 2, but now you have this bulky device and then you have to connect it to a computer. You wanted to take that a little bit of the concept and then make it into an embedded platform, basically.
Yeah, that's exactly right. So allow it to be small, allow it to be modular. That was another pain point is even some of the devices were pretty awesome, but you know, they're just products, right? Like you can't like take and connect and like, you know, actually put it in your like submarine or like put it on some small thing that goes on a bike or a million other applications.
So that was way too expensive as well.
Yeah. And then there's also the infrared. So like back in college, actually, so this all like comes together. I did the SparkFun autonomous vehicle competition. And like my first idea before I knew anything was to just use a Kinect. Cause I was like, look at how good it scans things. Like you can do rules and then I took it outside and it didn't work at all. Right. So that's another like advantage of this passive solution is, you know, as long as like you can see, okay, this will perceive the world okay too. So you can use it outside, you can use it at like relatively long range, you can use it real time. So yeah, I would say embedded, the spatial portion, real time, and then it's passive. So it could potentially do nighttime. It's not super optimized for that. They are very low light cameras, high sensitivity cameras. So it's kind of application dependent on nighttime scenarios. It is open source hardware as well. So you could actually use, these are not capable of seeing infrared, but there are alternate OV9282 modules that can be purchased and used with it. And we have tried out like 2 different variants that are IR capable. So in like dark nighttime applications where there's like a human can't see effectively, that would probably need some like custom work. So you use like an infrared illuminator or something like that, which is something we've played with. But some night scenes, like we have some test data we could share, it can still see like decently well. So like yes and no.
Yeah. No, I get you. Like you start off at one point and then you move on to the next. So depending on the scenario, people can retrofit it for nighttime, or if they need it for specifically daytime, they can also have that. So I see that your kit comes in 2 flavors, so OAK-D and OAK-1. It took me a while to figure out what OAK was until I realized it's OpenCV AI Kit. So that's what it stands for. I know you've already mentioned what the difference is, but can you just briefly sum it up, what the difference is between the two?
Yeah, so one of the value adds of these is like you can actually just embed them into products. So the main thing we were trying to solve is this spatial AI. So I've got it on the mount here. So what an object is and where it is, or what a feature is, a pose in the 3D pose. But not all problems. There's actually quite a few, like automatic sports filming. If you don't want statistics, you don't want to know physically where players are, but you want to know where the action is and film it and encode it, like do 12x lossless zoom onto it sort of thing. That's where OAK-1 comes in. So it's just that you can see there's a lot of parallels here. It's just the single camera brother. It's kind of like you ripped off the wings here. So that's what that's for. If you don't need spatial data, but you need a high quality camera, so it's 12 megapixel. It has all these dedicated computer vision functions of the Myriad X enabled in there. So you can do really interesting things like sports filming has been a popular response so far. So the idea there is you can do motion estimation, or you do object detection, and then use that to choose where you're going to crop and zoom. So it's 12 megapixel camera, so you can zoom to 720p video losslessly, pixel losslessly. So like if you're watching football and all the action is just in one corner of where this thing is placed, it can zoom in 12x losslessly and just record that and output 720p video, or it can zoom in 6x and output 1080p. So that's the use case for these. And then other use cases where you don't need spatial data, but you'd really like for the thing to be embedded and small.
Or if you want like real-time object detection or real-time pose estimation for that. Okay. How did you determine the optimal disparity between the 2 cameras?
Yeah, like the separation. So that's a great question. I think what you're asking is like, how do you choose, like, what is the baseline here? So we actually did it based on, we just Googled human sight, like what is the separation between our eyes? And even like on this video, I can tell, I think mine are a bit narrower than yours. Like apparently I have narrow separation. But like the widest of the range is 7.5 centimeters. And we wanted to kind of parody human-like perception on an embedded device. So that's actually what influenced making this 7.5 centimeters.
And
so
the larger you have it, the further you can perceive depth, isn't it?
Yes, that's right. So this is fairly comparable to like a human like doing some specific task, is like detecting bad onions, or looking for an impending crash or something like that. It's very similar. We do, since it's open source, and I actually have this on my desk. So there are variants, and this is on our GitHub. Let's see if I can hold the thing up. So this is an OAK-D. So it's all the same capabilities and everything, but then it's got modular connectors. So we do have folks that are wanting to see like super far away, for example. And you can see this can do quite a long baseline. So it can do, instead of 7.5 centimeters, it can do, I think, 25 centimeters.
So the OAK-D is basically connected via ribbon cables internally to the correct depth.
Yeah, so on this model, there are actually little ribbon cables like you're mentioning. And then the cameras are hard mounted. My camera is not amazing here, my iMac camera, but you can see those 2 there. And so this is the OAK-D unit, but say if you wanted a different baseline, backers could go ahead and get one of these, and they could prototype their own baseline. Or since it's open source hardware, they could actually just modify this as well. So they could change the baseline to 2.5 centimeters or 5 or whatever they'd like, all on one board.
I see the power consumption for the OAK-D is 4 watts.
Yes.
And then the OAK-1 is 2.5 watts from what I see from your FAQs.
Yes.
Okay. It's quite low powered. Yeah, so compared to what I used to use back in the days when I was doing my master's in engineering, We were looking at the Bumblebee. I don't know if you've seen that device.
I
It's a,
have. I'm not remembering the specs on it, but I'm gonna Google it real quick.
it's a very, I think it's called the Bumblebee 3.
I'm looking at
Okay, it's taking me to the movie.
Yeah, me too. It got taken by Transformers apparently.
Yeah.
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 Oh, and then there's a Transformers 3, which totally is messing it up too, isn't it?
We'll find it later on. But back in the days, that was a really expensive camera to use, and your price is just like way below that, so it's more affordable for like the student, for the hobbyist.
It's more tractable too for like
Mhm.
installing into a device. So being under 5 watts is kind of
Yeah.
like that inflection point that if you're under 5 watts, figuring out a cooling mechanism isn't too hard. If you're above 5 watts,
Mhm.
generally it gets tricky or you need a fan.
Mm. Or heatsink.
Yeah.
Yeah. So regarding the hardware of the OpenCV AI kit, what's powering these units?
Yeah, so this is the Movidius Myriad X.
Mm-hmm.
So it's a really interesting chip, and that was part of the reason we went. Well, like the main reason we went
Mm-hmm.
down this path is we were trying to solve that like life safety application, and we could prototype it with off-the-shelf components. So this is the Myriad X directly on their tiny little chip.
You'll find it in the neural compute stick.
Yeah, it's the same as in the neural compute stick. So
Mm-hmm.
here's our OpenCV AI kit, the modular board. Here's the neural compute stick. And the chip's super interesting. So there's a bunch of geniuses effectively who kind of foresaw this spatial AI thing coming together. And so they architected this chip it's a network on chip. So it's got all these modules. It's got 2 neural compute engines, and that's all that's really used in this. It's got 16 shaves, which are also used to assist neural inference, but
Mm-hmm.
all you can do on this is neural inference. And then it's got stereo depth hardware. So it's actually hardware
Mm-hmm.
modules in there. It's like 3 of the D4 processors in the Intel D435 or 455.
Mm-hmm.
It's got a bunch of hardware acceleration for like warp, dewarp, motion estimation. It's all these like individual processors for dedicated common computer vision tasks. And then they're linked together on what's called a network on chip where you can prioritize their connections. So you can do these really interesting use cases. And that's what our pipeline builder exposes. And that was the original intention of the chip. That you can say do motion estimation and then feed the results of the motion estimation region into an encoder. Or you can feed that motion estimation into an object detector like YOLO. And then that is what can do your automatic sports filming or knowing what's a good onion and a bad onion. And that's all. So the OpenCV AI kit, the whole premise is it makes that easy to use and accessible. Whereas this, you can only do neural inference. When you use this thing in the OpenCV AI kit, you get all the crazy powerful functionality and kind of drag and drop flexibility
Mm-hmm.
is what we've implemented. So you can like tie all those pieces together to solve
Mm-hmm.
really complex computer vision problems,
Mm-hmm.
just putting this in your product
Yeah.
effectively.
Basically, you've unlocked the power of the neural compute stick, and you just gave it wings, or in this case, eyes, and
Yep.
be able to do a lot of wonderful things with it.
Yeah, that's exactly right. So it's unlocking the power of the Myriad X, like the
Mm-hmm.
original vision. I don't know who originally architected, but I would
Mm-hmm.
hope that they see this and they're like, yes, like someone did it. Right?
Finally,
This is
someone
what the chip is for. Yeah,
someone put it to good use.
yeah,
Okay, so how do these devices or these kits compare to something like the Jetson boards, like the Jetson Nano, the Google Coral? Why would people
yeah,
buy your kits over the already available alternatives? And what sets your boards apart?
yeah. So one of the things is all like probably the main thing is like completely integrated like spatial AI. So with like a Google Coral or NVIDIA, like Jetson Nano, the Jetson series is fantastic. Coral is fantastic. They do a great job of kind of like modular, especially the Jetson Nano, like modular, flexible neural inference. But if you want spatial data, then you have to go ahead and like buy a depth camera, right? So if
Mm-hmm.
you're trying to build a product, you have to buy a depth camera, you have to buy a Jetson Nano, you have to integrate them together and write your own stack. So the big differentiator here is, say, the Jetson Nano. This is also faster, but that's not like the main reason to buy it. The main reason is you get all of that integrated together and it just
Mm-hmm.
works. You don't have to
Yeah.
write all your own integration.
Mm-hmm.
You don't have to have USB cables going between the various things.
Mm-hmm.
You can even, buy the module, hook it to some microcontroller, or not even have a microcontroller, just run MicroPython on it
Mm-hmm.
to like command and control your robot.
Okay.
And so that's the main one, is the spatial portion. It's all
Mm-hmm.
integrated spatial. It's like you took a Jetson Nano and like an Intel D445, 455 and like had a baby, right? And it's just like one thing.
Yeah.
So then the second advantage is like this is actually just a straight up embedded system. So whereas Google Coral and Jetson Nano are running full versions of Linux, which can be great in its flexibility. If you're trying to do a really low power embedded situation, say you put this on like an e-bike or an e-scooter, like you want it to be off most of the time, but you want it to turn on immediately when the person like hops on the bike and runs.
Yeah.
So this has like 200 millisecond boot time, right?
Wow.
Because it's just pure embedded.
Yeah.
Whereas with Linux, like, I mean, if you're like a super genius, you're crazy good with Linux, maybe you can like pull that off, but it's a ton of work, right?
It's a lot of work.
So yeah. So the other aspect, say even when you don't have the spatial, is you can embed it into something and you can do the crazy low power modes. And then in terms of specs, so the like neural inference, this is a bit faster than the Jetson Nano. It's not quite as flexible. It's that trade, right? Like Jetson Nano is just a GPU. So you do have to compile models and stuff for this, but it's about 4 trillion operations per second total computer vision like horsepower, and the Jetson Nano is 0.47. So when you're using all of those features, all the computer vision and the neural inference, it can do quite a lot more. And then in terms of straight up neural inference, it's about maybe like 1 to 2, depending on what you're doing. So whereas it's like 0.5 for Jetson Nano, this is like around 1 to 2. So it'll generally be faster.
Yeah. I'd like to see a comparison between your board versus other boards in terms of like object detection, pose estimation, and a wide variety. Maybe in the future we could see something like that, like a side-by-side comparison. That would be great.
Yes, exactly.
Yeah.
So we've only done like very initial ones right now. So like a TRT optimized Jetson Nano gets like maybe 20 to 30, if I remember correctly, frames per second. Correct me if I'm wrong. Running like MobileNet SSD. And then we're seeing about like 40 to 50 on these boards. So you have to do an option that increases the frame rate on the cameras to enable that, because they're by default 30. So that's about where we land. Oh, and I didn't cover the Google Coral. So the Google Coral is 4 tops of neural inference, whereas this is like 1 to 2-ish, and then it's 4 tops for everything. So when you're doing all the computer vision functions too. So straight up neural inference, the Coral will be faster.
Yeah.
But it doesn't have all those other computational capabilities.
Exactly.
Yeah.
Okay. Now with great hardware comes great firmware and software, right? What is the API like?
Yeah, so first it's MIT licensed, and and same with all the hardware. So you can take it and not talk to us and go integrate it into a commercial product. The goal of the API is just to make it super flexible and easy and discoverable. So the discoverable portion is probably the most important. That, like, I kind of made up that word for this application, but what we do is like you plug it in, you literally like run like one command, and it's just like a test example command, and you see the spatial AI, right? And like everything's working, and you're like, well, interesting. And could I use this model? And then like you just try that model instead, and it works. So it's kind of like an Apple, like it works, and you don't know why. But then to make that discovery really easy. So you're like, okay, well, it works. I'm super excited. It mostly solves my problem. How do I go to the next stage? Then as you start to dig in, you're like, oh, holy cow, there's a whole bunch of options here that I can use and I can exploit and customize. But they don't like smack you in the face initially. They don't get in your way to get the thing working. It's all about like, it just works. And if it already solves your problem, you don't have to dig further. But then if you want to customize, there's a whole wealth of options, like video encoding options, like customizable pipelines. So you can string all these functionalities together. And you can do that with simple commands to build the pipeline, or you can do graphical, or you can have something directly export JSON. So it provides a ton of flexibility when you want it, but you don't have to, that doesn't get in your way.
So it's basically normally when you get a new piece of hardware, you like take it, you have to try and figure it out. You have to know some background programming language, or like a lot of experience behind the stuff that you need to implement. So you probably answered this before, but how is it for a student or someone just getting started, like a graduate or even a hobbyist, to get started with your kit?
Yeah, that's thanks for bringing that up. So we're making the whole API flow and then the initial user experience with the API, so that an artist maybe it's an artist who's made a sculpture with like servos in it, but like isn't a programmer, doesn't come from a technical background, but just like wants to make an interactive sculpture, make it so they would be able to use this like with just like one change of line of code, just like looking at a tutorial, put a pose estimator in there, and then you have like a sculpture that's like following your pose, right? So the goal is to make it trivially easy. And then diving down into the specifics of that, we use pip install. So it's just gonna have straight up pip install support. So you like get the unit and you just say pip install the library. And then for, you're running Mac OS 10, you're running Ubuntu or Raspbian or any common operating system will have pre-built everything. So it's open source, but pre-built binaries that bind to Python. And then there's also C++. But if you're running some other form, it's open source. So like Windows, for example, that will also be pre-built, but let's pretend it's not. Then when you do pip install, it'll actually just build it from source, installing the tools that you need, build it from source for that, and then just run.
So this won't only work with Raspberry Pi, it will work with all operating systems. So if I just do develop on my PC and then transport it to Raspberry Pi, I can do that.
Yep.
Okay.
That's exactly really right. Awesome. And the idea is like, when you're prototyping something, you just want to plug it into your computer and see what it does, right?
Yeah, exactly.
So we need that user experience to be awesome, because if it's a huge pain, like, it's a super busy world, people have a lot of options, a lot of things to do. You just walk away and you do something else, right? Like it's hard to get running. And then the transition there is it works on your computer. You can go use it on a Pi. It's really, we actually have a video showing the setup on a Pi. It's like 30 seconds. And then the next transition is we have like an SPI, so serial peripheral interface for just straight up microcontrollers. So you can start on your computer, you can go to a Raspberry Pi, and then you want to install it in something that doesn't even have an operating system. We have an open source SPI interface and a variant of the module that just boots by itself. So then you can build it into your little robot, or put it into some cost sensitive product where you don't want to have a whole Linux operating system.
Exactly. Wow. Yeah, that's really amazing. I mean, why should building something be hard? I know you learn a lot from debugging, but you also learn a lot by building and progressing in your work as well. So moving on to the program interface, I saw that there's a drag and drop visual program interface called Pipeline Builder. Can you tell us a bit about that?
Yeah. So the quick background there is we envisioned use cases based on like our initial customers who've been using these systems and the feedback they need, like being able to run neural models in parallel like our eyes do, or being able to do disparity depth and being able to do encoding. And so we have this, in that like rendition, we call that Pipeline Builder Gen 1. There's kind of like this very fixed number of permutations and flexibility. You can do like so many series neural networks. You can do so many parallel. You can like, it's somewhat rigid. So the Pipeline Builder Gen 2, which is what's covered on the Kickstarter, is we saw there were some pretty complex flows of computer vision functions that specific customers would want to build and then have run performant on the MyriadX, and it had enough resources to do so. So we kind of set out with the pipe dream of like, wouldn't it be awesome to just have a drag and drop interface, right? Like I had like motion estimation off of the color camera, right? And then I would like to run a neural inference, like an object detector, YOLO, only on the pixels that have motion, right? Say if it's a fixed camera, like watching a soccer game or something. And then that lets your object detector see further, right? Because instead of decimating from 12 megapixels down to, the YOLO's, I think 416 by 416, right? So you're losing a ton of information. If there happens to only be motion in the corner of the field, right? It's only like 300 by 300, then the full 416 by 416, and that takes your YOLO object detection distance from like, let's say it's like 80 or 90 feet or something, to like hundreds of feet. And that's just one example. So we wanted to make these hardware, or expose these hardware blocks and then our firmware that's running on there in this drag and drop way, which is a ton more work because you have to make all the inputs and outputs compatible and manage resources and keep it high performance. But then it allows folks to take this and implement their entire computer vision flows using these blocks. And so the Pipeline Builder.
So if I want to take something like, I want to do gender classification, or if I want to do number plate recognition, I can stack different flows on top of each other. And then in the pipeline, that would give me my output from that.
That's right. Yeah, and so that's such a perfect example. And actually, when we were architecting the Pipeline Builder, we took the number plate recognition. So it's like vehicle detection, vehicle like make model detection, then license plate detection, and then OCR, and like strung those all together. And then we did a whole bunch of similar ones like that, where it's like, person detection, like what is it, like age and like emotion detection sort of thing, and then also like re-identification, string those together so that folks could then build those apps and then any other flows that they want. And it comes down to like 3 modalities in the Pipeline Builder. So there's like maybe 12 or something very very fast accelerated functions. Like neural inference is one of them, disparity depth, all those sorts of things. You can drag and drop those however you want. But say on your like age and emotion recognition, for example, in that case, maybe if a bounding box is too small or too big based on person recognition, you don't want to do the age because you know it's going to be wrong, right? Like in some little corner, you know it's probably on a poster on a wall or something. So we also support another modality is running MicroPython as a node. So you can still have this performant flow with no host at all. And then MicroPython can do rules like throwing away bounding boxes that you've decided are in the wrong location or the wrong size. And then there's also OpenCL support. So if of these first computer vision functions, like if you don't see the one you need, you know, we have this list of ones that are hardware accelerated, and maybe you have your own proprietary computer vision, you can use OpenCL to transfer it and then run that as a node accelerated by the 16 Shave processors on there. And you can drag and drop all those together, just like you were talking about.
Wow, that's amazing. Okay, so how do you see these kits being used to combat real world issues like COVID-19? You know, the world is plagued. We need to get over this.
Yeah. So in a variety of ways, probably the one that's like is probably the most important and most interesting. Maybe not most interesting, but the one I just didn't think about, and so it was like fascinating to me when it was brought up as a result of our Kickstarter. Is visually impaired people right now are suffering depression at levels like they have never been seen before in the history of the world, because you go out if you have a visual impairment and you end up being too close to someone and you don't realize it. And so you get yelled at or you have things thrown at you because you just can't tell you're close to them. And then worse, a lot of them after they have this experience, a lot of these people after they have this horrifying experience, because you're too close, someone gets mad at you, you could be contracting COVID-19 and you're unaware of it, just stay home. And so suffer like lack of mobility, lack of capability to do things because they're afraid of, you know, getting ostracized or catching COVID-19. So one of the coolest things we've seen, like heartwarming things we've seen with the technology, is there are OpenCV spatial AI competitions sponsored by Intel. I think there was like 55 or 60 entrants on doing blind assistance devices. So it uses this spatial AI to know things like where are people with and without masks, that sort of thing. And then that lends itself to a more, so that's helping visually impaired navigate and have mobility and be safe in this, you know, weird pandemic era. But it lends itself to other applications like social distancing monitoring, contact tracing, like in a warehouse, for example, like reminding people to stay separated. You could detect, did people have masks on when they passed each other, right? And you can log that. And if you wanted, you know, a company could then use that to like backtrace, like, oh, that we had an employee and here are the people that he interacted with when they
was
both
in contact with those people,
right?
and then we need to isolate those people.
Yeah, exactly. And then there's other applications like robotic cleaning, having like UV cleaning robots that can wander around and just sanitize the air to get like the aerosols, the viral aerosols out of the air.
Like robot nurses as well.
Yeah, exactly. So there's and then the whole like delivery boom too, right? Like this spatial AI allows like navigation to be a lot easier to actually do delivery robotics and so forth. So yeah, there's I think a ton of good that this can do for enabling, you know, lower cost, more real-time solutions like that.
Are you able to do SLAM on this device?
Probably. So traditionally, like if you take a stereo camera, right, it's like, what do you use it for? A lot of times the answer was mapping, right? Like making a map of someone's head or making a map of a product or making a map of a room. And then for navigation purposes. So yes, it has a lot of the things built in that would help with SLAM, right? It can produce depth outputs. It can produce like feature tracking, which is both key point detection and optical flow, very useful in SLAM. But we're not architected to be a SLAM camera. So if you took like a camera, and there are very good SLAM cameras out there, if you took one of those and used it instead, you'd probably get better SLAM results. Now, there are some interesting use cases of SLAM when you have AI on board. So like take a Roomba cleaning a house, for example. Those use SLAM and they get confused, and a lot of robots get confused when you move your couch and your furniture around and just, what the hell is happening? Because it doesn't know that's couch or furniture. And so the map gets totally messed up and it loses its navigation reference points. So if you can run AI on device, which this can, then you can know as you're passing something that's a chair or a coffee table that's going to move often to not throw off your map, right? So like ignore that whole section as it's going by, or when like a person's walking by, you know it's a person. So yes, it can be used. And our advice would be, you know, use it if you only are planning on like leveraging the AI aspects of it. If you're just wanting to use it as a algorithmic based SLAM, you know, use one of the amazing SLAM cameras that already exist.
Okay, cool. So how do people watching this video get their hands on your kits, and when can they expect the delivery? Where will it be available?
Yeah, great question. So our Kickstarter is kind of like our bulk order to like,
Mm-hmm.
we're using Kickstarter in the premise of Kickstarter, which is like, it pretends like every person is like someone ordering 10,000 of them or like
Mm-hmm.
100,000 in terms of the
Mm-hmm.
pricing. So get the price as low as possible, do one big bulk order together so then everyone can get the best possible pricing. But the trade on that is time.
Mm-hmm.
So the Kickstarter, like even our suppliers, they have to order the supplies to build their camera modules at these
Mm-hmm.
volumes. And most of those are like maybe 10 weeks to get those back, 12 weeks, something like that.
Mm-hmm.
So the Kickstarter delivers in December and we don't hide that. We put that right when you check out. It says delivers in
Yeah.
December. But there are units available now. They're just more expensive because all the components are like 2 or 3 times the price
Mm-hmm.
when you purchase them at low volume. In terms of where can it be delivered, pretty much anywhere. So there's the U.S. embargo list, so we
Mm-hmm.
can't deliver there. But this gets classified the same as one of these guys, a
Yeah.
neural compute stick or a
Like, would you
camera.
be
So
able
it
to get
can,
it like at your RS components or your Mauser or DigiKey, those sorts of places?
yes, yeah. So it will be on Mauser theoretically soon. some
Mm-hmm.
like some
Yeah.
like glitch in the background, but you'll be able to buy it on Mauser.
Yeah.
We haven't talked to RS Components or DigiKey or those folks yet, so
Mm-hmm.
it's primarily Mauser at this point. But likely, very likely, I'd say, because and I can't speak for each one, but the idea behind the Kickstarter was to really get it out to the world, and
Yes,
so
yes.
then folks are like, oh, this is a thing, and then we
Mm-hmm.
can carry it to various distributors. That is the plan. Yes.
Oh, yes, of course. Okay, so I see you're also planning to release a nice crash course there. Obviously, because you guys made it so easy and simple, would there even be a need for a course? But
Yeah. So it's a really good question, right? It's one of
yeah.
those things. It's like and the answer is there's always a need for a course because
Mm-hmm.
what this does is like, previously, and machine learning is getting so much better in this regard, right? Like, I was playing with networks in like 2017. It was like, cool. I spent like 3 weeks trying to get my GPU working with this library, right?
Yeah.
And like, then you get like an object detector running and it's like a huge victory.
Mm-hmm.
And so then like back then, the course was just like, how do you get object detection running? But
Mm-hmm.
now the courses can move on to like more complex implementations. Like, how do you do this type of scenario
Mm-hmm.
efficiently on the hardware? And like,
Mm-hmm.
how do you leverage it? And here's some really interesting things that you could do that you might not know immediately. And here's the
Exactly.
example flows. So it just moves the problem space that you're
To
covering
another
from like,
place, yeah.
yeah, to this more
Yeah.
complicated solving like a
Mm-hmm.
systems level problem instead
Yeah.
of just how do you get like a basic component to run.
Exactly. So just like our course, we were trying to teach YOLO V4 how to get it up and running. Even
Yep.
though you do have like GitHub repositories showing you how to implement it from A to Z, but
Yes.
we were thinking, how do we take YOLO V4 and implement it to actual products or actual projects? So we
Yep.
implemented a mass detection like you had, social distancing monitoring as well. The other one is also using a cough sneeze dataset. We're trying to detect if someone is coughing or sneezing.
Oh,
So,
cool. Yeah.
we're trying to have all these different applications to make it a bit more fun and more exciting rather than just, okay,
Yeah.
how do I implement it? That's it, done and dusted. So we did speak earlier about collaboration course. So people who do buy the kit can also learn how to use it and watching the training and tutorials and course, which will be first on Augmented Startups YouTube channel and also on our website. And lastly, if people have any questions, how do they contact you?
Yeah, so there's a variety of ways on our Kickstarter. They can feel free to post, like if they're backers. We have a discussion forum, so
Mm-hmm.
it's discuss.luxonis.com. We also have, if you go to luxonis.com or docs.luxonis.com, there's a whole bunch of information there on how to use like what exists now and how to use it. And at the bottom, you can join a Slack channel. So we have a community Slack channel, and there's a lot of really interesting discussion and use cases there. And then folks can just email me. I'm Brandon at opencv.org or Brandon at luxonis.com. So email us directly. Yeah, and then also on GitHub. So we have, everything's open source. All the hardware that's built around, this module, and then, of course, all the host code and training and everything. We have those example networks. So in each respective one, if you have an idea like, hey, I would love to see this version of training, or I'd love to see, this example or this new board feature, folks can make a GitHub issue and tag one of us.
Yeah.
So any and all of those, probably the fastest is Slack, I would say.
Yeah, a lot of people are using Slack these days.
Yeah.
Okay. All right. That's all the questions we have. Thank you, Brandon, for joining us. It was a real
Yeah.
honor, and I really look forward to playing around with one of these kits when I get my hands on them. I'm sure a lot of people on our channels are also quite excited. Also, for those who are looking to learn AI in computer vision, I have courses in YOLO version 4, object detection, OpenPose, Mass RCNN, as well as my course on augmented reality. And you can check them all down and also get Brandon's kits on Kickstarter down below. Thank you, Brandon. And
Yeah, thanks for your time.
see you
I
soon.
really appreciate it. Yeah, talk soon.
Cheers.